Hello, and how's everyone doing in the galactic family world tonight? We have a wonderful guest for you tonight. The topic will be quantum pass, Raelian science, the vision of Natália Morais. And I hope I said that right. Natália is a physicist whose work bridges cutting edge science and the quest for deeper understanding of existence. With expertise in nanotechnology, optics, and quantum computing, she has contributed to research at the frontier of technological innovation. Beyond the laboratory, Dr. Maurice is deeply engaged in philosophy, consciousness studies, and the dialogue between science and spirituality. Her curiosity drives her to explore how advanced physics resonates with questions of meaning, origin, and humanity's place in the universe. She's originally from Portugal. Now she resides in Japan, where she continues her pursuit and both her professional research and her passion for exploring the intersections of physics, spirituality, and the Raelian vision of science, a perspective that challenges conventional paradigms and invites us to reimagine the future of human knowledge. Let's pull her up on the screen right now as I welcome also my new guest, who is now my co-host, George. George is from the UK, and he'll be joining us as my new co-host.
Hello, hello. And
Let's
hello,
welcome
Natália.
Natália.
Hello.
How's it going?
Not too
Natália,
bad.
how are you doing tonight?
Very well. I actually am in Japan, so I woke up not long ago.
I was gonna say not tonight. Tonight for me, morning for you. So, what first pulled you towards physics? Was it a question, a teacher, or a phenomenon that happened to you?
Well, since I was very young, even in elementary school, I was already drawn to numbers and mathematics. So I found the way I use my brain to find the answers to mathematics very satisfying, let's say. And when I started learning physics in school, it was later. Then I was just surprised and how interesting it was, and so I just decided to continue and pursue the study without even having a strict plan to it. I just followed my passion, let's say.
Wow, that's wonderful. George, you got the next one?
Yeah, I'm just going to follow on from that. What area of physics did you really specialize in? Theoretical or
During my study, I specialized in the photonics,
photonics?
not necessarily quantum photonics, but then I joined the quantum computing research field right now, and I'm working with the electrons on liquid helium for quantum computing.
Okay, cool. So could we say that like optics and photonics was a real area of special interest from you from your formative years?
Yes.
And that's to do with light and light manipulation and like using that in electronic circuits or photonic circuits and those kind of things.
Yes.
So yeah, that's cool. How long were you in study? I mean, like obviously study is ongoing, education never ceases. But
Yes.
how long were you in university? Was it like like to do your doctorate?
So so up to my master's degrees, it was 5 years. So it was the after the time they condensed these university studies. Before it used to be longer to get a master's, and then a PhD was about 3.5 years.
Cool. I'm curious as to your theses, the things that you put forward for your masters and your PhD. That's a level of education that I do not have, and I am very much an amateur lay person reading the news and these kind of things. So I'm not at the cutting edge like yourself, Jay.
Yeah. So Portugal to Japan. That's a journey. How did the cultural shift change your research style or your collaboration habits? Like, was it more collaborative there in Japan?
No, it actually was less. um, so it is. So I had to adapt to the culture, which is very different, even though superficially it might look the same because we have the same economical structures, let's say, especially between American and Japan. There are a lot of similarities in terms of economics, but in terms of culture, is completely different. And so, Western person that arrived to Japan might think you're gonna find the same ways of working, but it's completely different. For example, in the West, things are said more clearly, and the indications are given more clearly, and errors are corrected verbally. Let's say everything is done very verbally. While in Japan, you're expected to know what you're supposed to do, even though sometimes it's not very clear. And I feel like there is this. I'm just speculating, of course.
Yeah.
Almost this telepathy environment where people kind of know what to do, and without being told. And but in fact, it's detecting subtle cues, more of detecting subtle cues. And of course, Western people, when they come here, are clueless, and Japanese people expect them to work the same way as them. But
Yeah.
yeah, so I had to overcome that issue for a few years at least.
Okay. George?
Yeah, we've got a question here. I'm going to alter it a little bit. The original is, what's a formative failure that quietly set you up for a later breakthrough? But I'm curious as to know, when you're in science and you're researching and you go down an avenue of discovery and then it yields nothing. Have you ever encountered those break points where you kind of go, oh, that was a wasted year, 2 years of research, these kind of things? But what was there a break point in your scientific outlook or your scientific research that you could share with us, where it was like, maybe a great success or maybe a negative or a positive kind of breakthrough or break point?
There is something that I'm still working on,
Okay.
but it's better right now. I used to have much more rigid pattern of thoughts, and that kind of prevents you to have a more open-minded to see the problem in the different ways.
Yeah.
So keeping my mind open is it was something that I had to do, and it's still a work in progress. And another thing, it's actually there is something very fundamental about working in science, which is you're searching for something that is true, something that is real. And for example, people have a lot in their daily lives. Um, Sometimes they are not so honest, either with others or with themselves. And but those patterns that you have in your daily life can be brought to the science. And when you're not honest about finding the truth in the science, it's more difficult to find. For example, you cannot expect that the universe will bend at your will so that your experiments will work. So this bowing to the truth of the universe, it's a very important step that you need to take before your experiments start to make sense.
Hard knock reality coming through with the experimentation. Yeah. It's like it behaves in a certain way, and that's that, and you can't get around it. Jay?
Exactly.
Yeah, I totally agree. You get what you get, and in the end, you then go through your motions like you would as a scientist, and you figure out the different pieces that you either had a success with or had small failures with along the way. But eventually, it turns into success.
Yeah.
Because that's science.
Persistence.
Yes, and so if you had to state like a north star in your research, what are you reaching for in research wise?
Well, how should I explain this? Well, especially since I started to study quantum mechanics, I realized that I really like this process of quantum mechanics, which seem very counterintuitive in the daily life, um, and of course we have these devices that now are functioning based on this quantum mechanic laws, right? And it's very interesting to see how these devices that work that we can see them work, and they functioning with this very counterintuitive ideas, and I just find that fascinating.
That's awesome.
100%. Yeah, this next question I'm going to read out in full. What misconception about quantum research outside of your research do you encounter with the public or Joe public? Like people think, oh, you're a quantum scientist, you must be doing X, but actually you're doing Y, you know?
Well, what usually people think, I don't really talk so much about people outside academia, to be honest, but also often what people think is that because it's quantum, you have like infinite possibilities and everything can be done. But actually, quantum systems are very fragile, and we spend most of the time trying to protect them. And there's a lot of errors that can come from the environment, and that's why most of these quantum systems are we use cryogenic setups. We use dilution refrigerators in the very low temperatures, millikelvin, which is lower temperature than space.
Pretty nippy, pretty cold.
Yes. So that is to avoid thermal noise, of course. And but there are other sources of noise, even if we will eliminate this one. So they're actually very fragile systems.
Yeah, we're gonna. Well, I think later on in some of we're might get into coherence and decoherence and what that means. Quick interjection, Jay, if you don't mind. Annealing or gate-based methodology for quantum?
What is the question about it?
Okay, so there are two methodologies for quantum computing.
Yes.
There's the annealment or annealing method and the gate-based system. Both have their advantages and disadvantages. If you could elbow into one segue, either annealing or gate-based methodology, which one would you prefer to have?
Right now, a lot of people are working on the gate-based methodology, which is more similar to the computers that we have now. The annealing is more of a physical process where you find the solution. You find the solution to a complicated problem by minimizing the energy. So it's much more specific to solving quantum problems, and while the gateways, it can be more similar to what we already have as computers.
Wow. Okay. Yeah, that's great explanation there. Thank you for that. And I think potentially the gate-based system is more universal, more low level. It's going to be more readily available, whereas the annealing methodology may be more specific for specific tasks, perhaps. Jay?
Yes, it might still the gate-based computers right now are still very specific. They solve very specific problems. They cannot be used, like for example, to access your bank account or something. But
or play Crisis, I think, is the online meme. Jay?
Yeah. So what concrete problem are you trying to solve this year, and what does that success look like experimentally, like in experiments?
so as I said before, I'm working on electrons on liquid helium for qubits, and we still don't have one right now, one qubit. So to have a qubit, you need long coherence time. So you need to maintain a quantum state for a long time so that you can read it and change it. and also you need to have short gate times, short operation time, so that you can have the largest amount of operations that you can do during this coherence time. So that is basically the stage that we are at right now, since we still don't have this quantum system. We have this theoretical prediction of this you need two-level system to have this a quantum bit or qubit, as it was shortened to. And we have this theoretical framework, and we have observed this quantum transition as well. But we need still have some issues to solve. Especially, we need more efficient delivery of this microwave source that we use to drive these electrons between the two states.
Okay.
Because this solves several issues, as for example, decrease the thermal noise. If you have a more efficient in delivery of energy, which is very important, the thermal noise in this type of system, and also decrease the noise done by the helium itself, because the helium is because it's a liquid, more specifically, is a superfluid, which means that a superfluid will cover everything. Like, for example, if you fill a glass with superfluid, it will fill the glass, and then it will overfill the glass and go to attach to any surface. But the point is, it's still a fluid, and there's some waves in this helium, which we need to deal with as well. Most of the time, we just go around it.
Okay. All right, George.
Could you please walk us through your favorite measurement or imaging technique? What's your favorite, day to day? You like looking at some kind of I hate this word, spectroscopy, or some kind of like imaging electron system to look at the data. What's your favorite measurement or imaging technique, and why it's decisive for you? Why do you really like this particular kind of measuring system?
Well, this sounds very simple, maybe, but my favorite might be the scanning electron microscope.
Right. Cool.
Yeah.
It's a big machine. It's quite a large machine, isn't it?
But exactly. So once you make fabrication in clean room, which I do that, let's say 70% of my time, and you expect that this device has these parameters that have been that come from our design, and only when you see it SEM, or the scanning electron microscope, you can see if this device will work according to our expectations. For example, sometimes we have short circuits because we have these electrodes that are separated with tiny gaps, which is a few hundreds of nanometers or less. And sometimes we have tiny short circuits that we obviously cannot see even at the optical microscope. So I need to see it at a scanning electron microscope.
Oh, cool! Like I can only imagine like peering into that realm of that minute realm of electrons, photons, and neutrons. All that kind of that detail. I can only imagine what that must be to do day to day. That must be really cool, and it is really cool. Jay?
Yeah, no, that's definitely awesome. That's extremely cool. Are there now? Where are the if you can explain, like, any sources of noise or error in your experiments, and how do you tame them along the way? Like, how are you doing it to like tamp the errors down?
So there are electrostatic fluctuations, for example. So we have these electrodes that control the position of the electron on our device. Sometimes these fluctuations prevent us to trap very small amount of electrons. For example, we want to have one electron, and so the easiest way to have one electron just to decrease the voltage so that most of the electrons escape. But this gives origin to very tiny fluctuations of the electrostatics, and we often don't have the same result. So in that case, we have no choice but to go around it. And one way to go around this is, for example, to shuttle electrons from another source and then divide them so that we can still have larger voltages and have single electrons, for example. And other sources of noise, it's the ripples on helium that I talked about before. And right now we don't do much about it. We just live with them. And other sources are, of course, thermal noise, which I'm trying to reduce by doing a better microwave delivery.
Okay.
Yeah.
Wow. Okay. So with your laboratory, and me being on as a civilian, I have an idea of what a laboratory maybe through my screen looks like. But if you can imagine your laboratory for a moment, your day-to-day place or places that you go to study and research, what would it take for an independent laboratory, or another laboratory to have the same setup as what you've got? What is it? I'm curious about the coffee room, the electron scanning microscope you've got there, the kind of the equipment that you have in this laboratory. Could you walk us through those different aspects at all, or?
George mentions the coffee room because he
Well,
always wants
hey,
coffee in the morning. He has to have it.
magic beans, you need that every day. Not everybody, but hey, for me specifically, I do.
Well, for me, I cannot have coffee because I'm extremely sensitive to caffeine.
Okay.
So we already have that. Maybe to reproduce my results, you need to stop drinking coffee.
Okay.
So to be more honest about it, so once we have a result, we want to publish it.
Mm-hmm.
And it all comes down to obviously to honesty. So
Mm-hmm.
if we want other people to reproduce our results, we need to be as transparent as possible in how we obtain these results, so that other people can reproduce it.
Okay, so with the writer, like online, we see, when you go for peer review, for example, when you have a set of results and you're happy that you want this kind of studied by other groups around the planet, would you say that the ability to reproduce your results on your from your experimentation, is that easy to reproduce for other laboratories around the planet, would you say, like to promote what you're doing there?
Yes, if they have the same resources. Sometimes we have limited resources and we cannot have access to the same material,
Okay.
the same devices and the same materials. So it might be more difficult to reproduce. I think it comes down to either we have the same resources to reproduce the experiment, and the person that published the results is transparent enough so that we have enough information.
Yeah. Do you yourself, as part of the team there, do you write the results? I mean, like, I'm curious as I said, my knowledge of science is very limited. So when you're creating, when you have a good result, and you want to say, okay, we can share this with the wider world, you obviously have to write everything in absolute detail, right the way down, so that the other people in the laboratories can follow the same methodology and then hopefully get the same result as what you've had in the laboratory your side.
Yes.
So how long just a curve question, Jay, if you don't mind, how long does it take to write all of that detail to then go, hey, look, we've done this? How long does it take? Roughly, how long does that take to kind of put together as a document or documents?
It depends on the person. Some people have different ways of registering what they do. I know a colleague of mine that likes to write every detail, and then she even makes graphics of the results and then print
Wow.
them and pass them in the like with glue in the notebook, laboratory notebook. I don't do that. I prefer a more let's say automated informatics kind of way.
Hmm.
If I make some program that will make a scan of parameters and measurements
Hmm.
and do this measurement with this scan of parameters. Uh, I usually put it in the program to give me the results so that and give me the parameters so that it will output them automatically. So I'm a bit lazy actually. So I program my experiments in a way that I already have all the parameters that are written and all the graphics that are come next to it.
That's intense, and I like the fact you kind of got an automatic system, because it's just like, writing by hand might be a little bit
Right.
18th century, I guess.
Well, yeah, I'm also very visual, so I like to see all the data
Hmm.
together, like in this in the informatic format.
Hmm.
Can be distracting for some people. That's why they prefer to write everything down. But that's how I function.
Wow, yeah, I can only imagine, maybe if I return to college and then university, maybe one day I could be almost, like there's amateur scientists and then there's professional scientists, and I like the fact that being able to talk to you today as a professional scientist, I'm getting a lot of information about what the reality is of day-to-day kind of work, and also finding out what you're researching. Over to you, Jay.
Yeah. Oh, I was just letting you guys go. So if you could add, I'm going to do this as a double question so we can move on to the next block. But um, what open source tools or data sets do you rely on or wish existed now? And if you could add something to your lab right now, no strings attached, unlimited funding, what would it be and why?
So we often need codes either for our simulations of our devices, like computer codes, and also for measurements. And often we can rely on codes that other people have done, and they are uploaded in websites like GitHub. And we can find the very interesting codes that someone somewhere on the planet, somewhere in China or the United States, have done, and we can use these codes, and we ourselves make our own codes and upload to so that they can be used, which is kind of a gray area because usually you're not supposed to share your research unless it's published. So but it works like that for now, and it's very useful.
Okay.
Yeah, so yeah, I don't know anything that I want to add to to our experiments.
Yeah, maybe to make it go faster, or to help you with your experiment, to make it go you know succeed, or
Unlimited
something
budget,
that'll
yeah.
groundbreaking that you could add.
So one thing, it's not really groundbreaking, but we are really annoyed by noise. So
Oh,
maybe some refrigerator with less microwave noise, and also a dilution refrigerator have a pulse tube, which means there are some constant vibrations, something that will dampen these vibrations.
okay.
And yeah, something that will reduce noise because the quantum state requires the lowest amount of energy possible, and when we have these perturbations, we introduce energy that you don't want.
Yeah. Okay. Thank you.
Cool. Okay, so into the next segment now, from optics to quantum. So from the photonic optical realm into quantum. What intuition from classical optics still works in the quantum regime, like in the range of quantum? At what point does it break down? At what point does or does it? I mean, this is an area I think you're going down, like using photonics for quantum processing. So like I'm trying to word the question that I've got on my screen here. Where do things get hazy? Where do things like when you kind of go from, okay, here's me with a laser and I'm firing through various kind of measuring devices, and then you go into the quantum processing aspect of that. So then in the, you know, then you have this photonics. Where does it begin to become complicated? I mean, like, not that it isn't complicated in itself, but where does it break down a little bit, and you're like, okay, we really need to look at this breakdown a bit more?
So, so as you know, when you treat a particle in the quantum way, you can treat it as either a particle or a wave.
Mm-hmm.
And photons have this advantage that they are a wave, either classically or quantum. So many of the things that we see in quantum physics, for example, interference and phase, coherence, and certain modes of light, this still works in classical physics. And the classical physics can predict very well the behavior of light in the classical way. And classical physics for photonics means that you just have a lot of photons. So we have so many photons, sufficiently amount of photons that we can treat the light as a wave only. But when you start going down to quantum, it actually happens with opposite. With the particle, you start treating the particle as a wave, and
Okay.
with photons, you start treating the wave as a particle.
Okay.
And what does that mean? It means that the particle doesn't have this beam type of shape, but this beam type of shape still has some meaning, which is the probability where the photon will be.
Right. I can only imagine the mathematics surrounding that, like flip.
It's actually very interesting.
Yeah, for sure. A quick question: Do we have the ability, like in our experimentations as scientists, to fire individual photons, singular?
Yes.
Wow.
We have the ability already.
I kind of suspected, but I didn't know. So thanks for that, Jay.
I'm listening to that and I'm thinking,
I'm like, it's a wave.
My brains are going into my feet because I'm just like I'm thinking about it and just like, my brain hurts.
It's a wave. You observe it. It's a particle, but in the quantum realm, it's flipped around the other way. So it behaves as a wave as opposed to a particle when it enters that realm. Okay.
Well, they both behave as wave and particle.
Yeah.
In the quantum realm.
But the like, and then you're talking about probability of where it will end up, like the kind of Wow. Do you got, like, I'm just thinking, like, with these high level equations, you know, if you got into gambling, could you be quite, you know, like, this just asking for a friend?
Well, gambling is still a very deterministic. It's not quantum, so
not yet.
Not yet. Yeah. Oh boy.
So that would be easier, actually.
Oh wow, that's crazy. That's mine. Yeah, okay. I'm trying to conceptualize that just as a concept, and I can only imagine. Jay, over to you as I process this in the background.
Sure.
Going, my brain is
like Planet Popstar was saying, you know, the double slit experiment.
But then when it gets to the quantum, it's flipped round the other way.
Either.
Wow. Wonder what that crossover point is. That must be a really interesting area, that kind of like in between.
The crossover, very interesting. So we have this quantum something called quantum dots, which is a tiny amount of material that is surrounded by another material, let's say. So, and in this tiny amount of material, we have a very specific level of energies that the electrons can have there. It basically behaves almost as an atom. And that would be an interesting experiment to see when does a quantum dot stops behaving as a quantum dot.
Mm-hmm.
But it usually comes down to the wavelength of the electrons. If the size of the device is much larger than the wavelength of the electron, then we are going to have classical behavior. Yeah, but there is obviously a crossing point that we don't know yet. It just it's if you want, it still behaves as quantum. It's just not necessary to treat it as such, because when you have a tiny quantum dot, we have very determined quantum levels, and with the very specific transitions. But as the quantum dot increases in size, these transitions become closer and closer. So at some point you can see them as continuous. And what is at some point? Maybe the resolution that we have to measure these transitions. Maybe.
Wow. Mind. Yeah. That's like, again, for people who are tuned in, lay folk tuning in here, there's the high level concepts here which you're elucidating really well for me. Certainly, I've got a lot. I think the next 2 weeks I'm going to be going. Okay, so I kind of got the double slit experiment, the observer effect, and then the probability wave into particle, and now kind of like the crossover into the quantum realm with these dots operating as okay. Yeah, that's my one of my takeaways today is understanding this realm that we're talking about. Jay, quickly.
Yeah. So are there underappreciated materials or platforms you think will surprise people in the next 5 years?
So I think I might be biased here, but I think electrons on liquid helium or any other type of cryogenic substrate, for example, neon, might be very interesting in the future if we solve the issues that we still have now. And another one that might be even more interesting because it has the advantage that we don't need cryogenic setups to work on is the photonics quantum computer.
Yes.
I think in the future that might be the main quantum computer platform.
Okay.
I imagine your fiber optic cable coming into your optical router or router, and then into a light machine quantum photonic processing device, and then really. And then I guess one of the evolutions on that would be using that as a means to use artificial intelligence in that realm as well. So quantum AI. But yeah, photonics, I think, correct me if I'm wrong, 2004, the Israelis came up with the photonic processor where it was just processing at a ridiculous rate. I think it's around 2004. You'll have to get back to me on that one. If you had to choose today, if you had to make a choice, better error correction and coherence versus more or better qubits, what would you choose?
Better qubits for sure.
Better qubits. Okay. Well, could you explain why? I actually, before the show, I said to Jay, I said, I reckon it's probably going to be error correction coherence, but I'm curious as to why better qubits.
Well, because if you have better qubits, you need less error correction. If you have right now you have a qubit and you need to have actually a logical qubit, you need thousands of other qubits to correct to make error correction. Okay. And this is not only just like a concept, a qubit. It's not a concept. It occupies physical space. So we want to save space, of course. And so if you have better qubits, we have a smaller logical qubits.
Okay. You see, because me as a layperson, I thought once you have a qubit, it's a qubit, but better ones, more accurate ones, then help solve the coherence problem, and you need less of them around to be able
Yes.
to get the result that you actually. Okay. Jay,
Yeah.
I'm learning a lot today, man. I'm just
I
saying,
am too. I
like,
really
like
am.
armchair amateur. I mean, I'm just a simple IT technician for 10 years, and now, like, wow. Okay.
What is a check that you have for your own work where you go into it and you say, let me check this before I say it's an advantage in quantum?
Well, so as I said previously, longer coherence, shorter gates. I think that's the largest advantage that we have,
Okay.
and eliminating sources of noise, and yeah, and also needing less correction, quantum correction qubits around.
Okay. And I'll just jump into the next one then, because we did answer that before. What's the most elegant nanoscale design you've seen recently, and what makes it elegant?
Well, it was a few years ago. I have seen this a very beautiful nano laser, which is a Mobius strip. Mobius strip. I forgot what was the team that investigated that. Uh, but their fabrication, I believe they basically sculpted this Mobius strip out of this material block.
Geeks.
And and it works with some modes that we call whispering gallery modes, which is basically modes around something circular. And yeah, it was just very beautiful to see. And another thing that I've seen a few years ago, this was before AI, but they used machine learning to transform one mode of in a waveguide. A waveguide is something that will carry a mode of light, and it's transforming this mode into another one by using this strange device with the shape is like full of holes. But the thing is that they found this device by using machine learning, and this it can transform one mode into another. And the device, you look at it, I mean, it doesn't make sense. I don't see it, but it's just machine learning that found this device.
Okay.
That's cool. That's
Wow,
cool.
that's really interesting.
Yeah.
Is it anything like the dodeca spheres that are found around with the holes in it? Maybe does it look like that kind of a device with those holes?
No, it looked like just a square with a tiny bunch of holes around it that I cannot make sense of
Oh,
it.
okay.
But
Yeah,
just,
yeah.
yeah, like
Definitely,
more tube.
definitely goes to show that AI as a tool for discovery is front and center in the
Yeah, oh, yeah.
scientific community.
Well, it was not AI yet because this was before AI, but
It was a
machine learning.
machine learning. Yeah, sorry, my
Yeah,
bad.
still it's pre-AI, let's say.
Pre-AI. Yeah. At the nanoscale, what do you think scientists are over-engineering? What are we over-engineering? And like what like usually in nature, simplicity rules.
Yes.
So what do you think? What do you think at the moment is being over-engineered?
Maybe things that look great in simulation, but you mean engineering as like predicting or
creation, like creating engineering? Like I guess Jay, the question I've got here is where are we over-engineering at the nanoscale, and where are we under-measuring? I don't know, like kind of.
Well, we need to take into advantage the real world. Let's say. I'm not sure if we are over-engineering anything, but what we usually do is that we expect this device to work in a certain way because it has these optimal conditions, which has no roughness, no surface charge, no anything. So, and when we make these devices in the clean room, then we have these sorts of problems, and we actually may want to include um, the fabricated device and reintroduce back the errors into the simulation, so that we can make an extra prediction and make these several iterations that we have, so that we have the best prediction.
Okay.
I'm trying to think of real world over engineering. When you go, why is that designed that way? It's so complicated when it could just be this simple. But yeah, for sure. Jay, sorry.
No, you're good. So here's one I'm going to throw at you. Device level ethics. If you design something that enables it for a dual use, like say it's going to help people, but it's government too, how do you evaluate that personally? Would you more go for, I want this to help humanity? I don't want a government contract per se, unless it's like no strings and stuff like that, or are you going for the government contracts to try to get the science out?
That's very interesting, because right now the funding for quantum computers in many countries is military funding right now. And being in Japan, I'm a bit safe of it, because Japan has they lost the war, so they have no right to research weapons, and so it's one of the reasons why I'm still in Japan. And yeah, obviously we don't want to do anything that will undermine the human existence, and coexistence, and the health of people, obviously. But this all comes. The problem is not the technology itself; it's how it is used. But I take care of where the funding comes from. I try to avoid funding that comes from military.
That's awesome. That's awesome, because that, you get the funding from the source, and then they want you to do something and you don't do it, and then you don't get the funding, and you're like, well, I needed that to finish this and now it's gone. It's better that it's a secured, like you're like, this person is on the same level as me, and we're gonna, ride this all the way.
Jay, shall I move on to block 5? No,
Yeah,
I think
go ahead.
okay. This next segment I'm intensely interested in. This is where physics meets the spirituality aspect of existence. I think, and you probably be able to tell me, Dr. Natália, was it Einstein who said God doesn't play dice?
Well,
And
apparently,
I think I don't know. Well, like, do you think he does, or it does? Do you think the the bridge between spirituality and physics, where it's a hard knock reality universe, and it's just like there is no spirituality, and then people who get, from what I've heard, when you really tunnel down into the quantum realm. Was it Niels Bohr's? I think somebody said, if you understand quantum mechanics, you haven't fully understood it, because it's a heck of a thing, or to paraphrase. But yeah, when you say you're exploring the intersection between physics and spirituality, how do you define those, or do you think it's all?
well, spirituality is connection, basically connection with other people, connection with yourself, connection with the universe, basically. And it all comes down to how we let's say connect to the universe. We connect through our senses, the senses that we know they exist, and maybe senses that we don't know they exist. And especially the brain, we don't really know how the brain works right now. And there are many parallels between of how we experience the functioning of the brain. Not, of course, nothing of this has been proved, and also maybe some quantum behavior that we might have on the brain. but nothing is that demonstrated. I just like to speculate. For example, when we have this sudden understanding of something that we have been searching, it might seem like this this quantum state that collapses into this understanding that we have.
I'm still trying to get my head around parallel universes, but it's interest or processing in parallel quanta universes to bring the result back into this reality. I think kind of what you're saying there about like being connected, the connection we feel with reality, being synonymous with spirituality is a very, very valid point. How connected do we feel? I think maybe perhaps in modern society, a lot of us are disconnected from that reality through the hyper reality of the internet, for example, although it has positives and negatives. So yeah, you know, like defining physics and then defining spirituality, not an easy question. I think the being connected in the spiritual realm and being connected in the physics realm as well. I think that's absolutely a valid point there. And how many of us feel disconnected these days? You know?
Right. I think there are two different ways of being connected, and there is the most common way, which is through internet and through information, and to getting as much information as possible so that we can decode, let's say, our world and the universe. And that can be interesting, but you know, the way of using our consciousness to decode the universe, it is important, but it might be limited. We may have other capabilities of our brain that we are using when we disconnect this consciousness. Maybe other parts of our brain or other ways that we have to understand that are not necessarily connected to intaking more information. And I think that's something interesting to speculate about.
For sure.
Okay.
Jay, over to you.
Yeah. Which spiritual practices have sharpened your scientific creativity or pattern recognition?
So often we want so much to find a solution that we use too much our consciousness to find this solution. And this work is important, but after a while we start going into loops and becoming more and more rigid. So of course we have to stop. Rest is important. Meditation is important. Going for walks and doing something fun, something that that produce these happy chemicals that help our brain being more connected. So it's not all about just grinding to find the solution, but it's very important to rest and meditate.
Okay, thank you.
Yeah.
George.
Where are we? Sorry, my brain. I was listening.
Oh, you're fine.
Intently listening. Okay. What's your test for separating genuinely testable mind-body or consciousness effects from placebo or hype? How do you know if your reaction is placebo or if your reaction is genuine? I think is what the question is getting at there.
If the action, I'm not sure if I understand.
Yeah, me also. What's your test for separating genuinely testable mind-body or consciousness effects from placebo or hype? I think what the gist of the question is, using your physics.
Yeah.
When you have a spiritual understanding, how do you quantify that? And what's your flow chart to go? Yeah, that's an interesting elevation of mind. I think that's what it's kind of saying.
Yeah.
I'm not sure if I know how to reply to that.
Yes, that's a pretty intense question. If not, no worries. We can move on, Jay.
Yeah,
no
go to the next question.
There's something I may speak about. recently Rael talked about this love particle, and he says that we don't know it yet, but the love particle is actually a graviton. Graviton,
Ah,
yes, it's a love particle, and I did think something. How do we might detect this effect on our brain? And he even said that in the Elohim planet they have these machines that radiate love, and right now on Earth, what we only have is our brain, which can produce these love waves that can influence other people. And I just tried to think about how we can detect this effect on the brain. So since it's a quantum effect, it should be difficult to create experimental setup, and I guess that we would have to find a way to detect gravitons and then find a way to detect gravitons coming from our brain, possibly.
are gravitons the same as gravimetric waves, or is all
Yes.
gravimetrics? Okay, so that's okay. And it's interesting that you mentioned like a love particle as opposed to a God particle or Higgs boson particle as a separate thing, maybe being linked to gravitons. And just within the realm of UAP NHI, there's a relatively recent discussion on the interface between conscious machinery or vehicles that are piloted by said travelers, and it could be that could be a missing link there. So I'm logging that one down, of graviton being a potential love particle, and whether we as individuals can emanate that in some form. I think we can. I think it's possible, definitely. Jay?
Yes,
Yeah,
I've seen many years ago some publication that a group of people in a city meditating for peace. They actually seen a decrease in criminality in that city.
Maharishi effect and its transcendental meditation. And oddly, I was talking about it with my girlfriend last night. She's studying psychology, and we were discussing this. Yeah. It's fascinating that just projecting peace and harmony can actually lower the crime rate in your local area. Just
And it's not the people that commit crimes that do meditation and then don't do crimes. It's other people that do the meditation and that influence the crime area, the crime committed by other people.
Fascinating, fascinating stuff. Jay?
Yes. If consciousness, let me see here. Let me see here. What am I going to do here? Can you, if consciousness research is to be respectable physics, do you have something that you would start with that you know is false and then add up from there?
Something that I know is false.
Yeah, like what is a falsifiable claim you'd start with before you look into consciousness, the research itself, to be respectable in physics?
So Rael talks about superconsciousness,
Okay.
which is the let's say the consciousness of, or the the awareness of consciousness. And he actually said not to think too much about it. You might go crazy. But previously I've talked about other regions of the brain that may have a function, and they only work if we turn off consciousness. And it's interesting to see that brain continues to work. There has been some scientific studies of what happens to the brain when people are meditating, and obviously brain still continues to work, and that would be interesting to see what if areas that might be related to superconsciousness, for example the pineal gland, light up during this meditation.
Okay, and I know there's been different experiments too on consciousness, like weighing a body when the body passes away to see whether or not the spirit has any weight, actual physical weight in, you know, this reality, if the spirit has weight. They've done that before, I know that. Measured a person before, right when at their point where they pass away, and they have like measured it, not consistently, that's why it's a still evolving, but they measured a loss of weight in the actual, like, I think it was like ounces or something, or minute amounts, but it was a loss after the body had passed away.
Of course, for Raelians, there is no spirit, there is no God, there is no spirit. Uh, but if that's something like that was measured, I would have to see. Then it might be some other type of because matter is energy and energy is matter. Something that is lost, some type of energy that is lost at death. That
Okay,
we
yeah,
don't know
because
what it
then
is.
it's like your consciousness is going on from that physical body into a quantum state.
Maybe.
But then energy changes form, doesn't it? You know, it's
Right.
neither
Yeah.
lost nor reproduced, it's neither lost nor produced, but it changes state.
Right.
So if there is anything above and beyond, then it would change state as
Yes.
opposed to being lost,
Yes.
truly
Yes.
lost.
Okay.
Yeah.
Yeah.
Right. Yeah. This is an interesting question you've done here, Jay. Could you describe for us a small or large, I think, actually small or large, controlled experiment you'd love to run that probes the mind-matter interaction? If you could go, right, I really want to tunnel down on how mind affects matter, how mind affects reality, and just, theoretically, I reckon we could plug this person in with this EEG or something. Like, what kind of experiments would you enjoy running to really, like, kind of get at the mechanics of how mind interacts with matter? Or
Uh,
would you reverse engineer it? Would you see how matter interacts with mind, and then like the like backwards way? I guess, I don't know.
well, so we've seen that on this meditation experiment that
Mm-hmm.
the mind affects at least other people's minds.
Mm-hmm.
And yes, I've talked about also detecting this love particle, and something interesting that we might do, but this is a very highly speculative level. It's for
Go
example,
on.
in a quantum system, if we do a measurement, we interfere with the system, so
Uh-huh.
we have a collapse of the state, and we observe this state. But before this observation, we have superposition of states. But because the measurement interferes with the state, we
Yeah.
have it's not something mystical whatsoever. It's basically we have a quantum system, and the measurement will interfere with the system, and it changes. It's not the same system anymore, and it collapses to one of the states. And it would be interesting to see if the brain has this quantum behavior, if the observation would collapse some hypothetical state that I
Mm.
don't know about, but yeah, I would have to think more about it. But it would be interesting to find this behavior in your brain as well.
Yeah, I'm beginning to feel that the brain, the 3 pounds of grey matter, and our nervous system, maybe more, is actually a form of quantum computer of sorts, wetware, like wet computing, and how we interact with our reality is becoming more and more interesting.
Yes,
Definitely,
of course, we
definitely.
have no proof of that, but
Not yet.
yes.
Although was it Sir Roger Penrose has talked about carbon has talked about quantum tubules in the brain and acting on a quantum, like conscious quantum level. So I think as we move forwards in time, it's more exciting, maybe more perilous for us, but it's more exciting to see where the lab coat people are coming out with, like, we've figured this out, this is crazy, and it's going to lead on to this engineering and these things.
Mhm.
So it's fascinating, all of that, and the bisection between three-dimensional physics and spirituality, and then actually the it's a blurred line. It's kind of like a
Mhm.
blurred area in between. Yeah. Wow. Okay. Cool. But yeah, I think an experiment to not have the observer. I think that's what you like. That not having the observer effect. Come up with an experiment to do. To kind of gather that information would be cool.
Yes,
Jay.
I cannot hear you.
Jay, your mic's muted. If you can hear me.
Oh, my bad. I'm
There we
going to
go.
reword this question.
Okay.
What out of what Rael has talked about with the science that he has witnessed, what do you think is the most valuable for us to go towards now?
Hmm. Uh, so let's say, of course, there is this human desire of being eternal,
Yeah.
and yeah, that would be interesting to find a way. So, as Rael explains, the process of Elohim being eternal is they clone a body in adult state already, but this body has an empty consciousness, and then they upload the consciousness of the brain um, of the one person into another person. So basically, they are recycling the same body.
Like
Another
farmers.
thing, yes. So another thing is also actually removing some gene that we have that actually makes us age earlier, because we were actually supposed to live about 1,000 years, and but they introduced this gene in our DNA to increase the aging so that we don't evolve too quickly. They
Okay.
found that would be dangerous. So, but about uploading and unloading and downloading our consciousness, that would be interesting. At least a way to start to see that if you're able to download our consciousness into some kind of support that maybe doesn't exist yet, maybe a computer, maybe a quantum
Yeah.
computer. Yeah.
Hmm.
That's awesome.
Like
Yeah,
I
I've listened to the whole entire audiobook, and me and Jerry talk all the time. He's mentioned you when you guys were in Japan for the retreat up that way. And it pretty cool. Wish I would have been there. Hopefully I'll be there next year. Or not next year, but the next time that you have it.
Yeah, it's next year, end of September, from end of September to early October, like about a week.
Okay, well, maybe I'm thinking of the 4 year or the 8 years when he gets voted back in for the council and everything. I think
Oh,
I'm
I see.
thinking of that.
But maybe it might be too late because he's almost 80 years old.
Oh,
So
I know. I know. So,
if you
but
want to come, you better come next year.
oh, I know, or else I'm gonna miss him.
Yeah.
Uh, so that's awesome. Go ahead, George, for the next one.
I wanted to skip ahead one, Jay,
Yeah,
because
go ahead.
yeah, just for the record, I'm not a Raelian Raelian. I'm not a
Really.
Raelian. I'm kind of on the edges with my own understandings, but certainly within the Raelian ecosystem. So the system of kind of like what's going on there has promoted or it pushes forward an agenda of scientific and advocacy initiatives. So advocacy, I guess, and scientific understanding. Um, how would you, Natalia, keep your boundaries between scientific standards and organizational messaging? So you kind of got. I guess the question is asking you how you balance your understanding with the realism, Raelian. Sorry, like my
Raelianism.
Raelianism. How would you balance that with your day-to-day work as a scientist? And actually, are they mutually exclusive or independent?
So the things that are most controversial, of course, in scientific community is evolution. and also the Big Bang Theory. So I don't work in either of these, so I'm good. But I see a lot even in scientists right now that I find extremely intelligent, or I thought that they were. They say, "Oh, we've discovered almost everything right now that there is to discuss." And I say, "We used to say that there is to discover," and which I found a bit strange because in Newton's time, people were already saying we've discovered everything that there is to discover, and then we discovered quantum physics and relativity, which has been about 100 years ago that has been discovered. And of course, they usually say, how do they travel at speeds that are faster than the speed of light? Because speed of light is like this limit. You cannot travel faster than the speed of light. And I reply, maybe they know some physics that we don't know about that makes it possible to do
maybe
it.
post-Einsteinian, maybe.
Yes, of course.
You know.
And so, or other type of let's say energy waves, or other type of just physics that you cannot even detect that it exists, and cannot even imagine yet. So of course. And then the Big Bang Theory is also a funny one for me because we often say there is we cannot create something out of nothing, but Big Bang Theory is basically creating something out of nothing. So
it's good for the kids, I guess, you know, like the young ones. It's just like, you know, in the beginning there was a bang and everything's occurred, and it's like, well, hold on, chicken and egg, you know, how can you get that?
Yeah, except the kids are adult scientists, so I don't know.
Well, it's an eternal. I think the thing is with the mystery of the cosmos, mystery of the multiverse, mystery of the quantum realm is that if people stand up and say, "Hey, we've got a big toe, we've got a theory of everything," within about a half an hour, they'll be like, "Hold on, we've just discovered something completely novel, which doesn't fit in with this understanding. So we're going to have to change the whole physics again."
Yeah.
But I like the concept of going from you know, postulating a hypothesis to then solidifying a theory, and then going from theory to a practical, and then going from practical to engineering, and then engineering to products to day-to-day usage. And I think kind of being in that chain yourself is benefiting mankind, benefiting humankind generally. And you know, this is I don't think that physics or science generally is mutually exclusive from spirituality. I think you can have you can be spiritual and be a physicist, and I think you could, you know, and everything in between. But it's just like I think the question was kind of pressing on: do you split those apart, or do you take that spirituality into your experiments when you're like working on things day to day?
No, of course I don't split it. Everything. It's very much integrated, and also
Right. Okay.
if you understand the mechanisms of the spirituality, I think that you can even enhance and amplify the experience of this. Feel like it's some resonance that happens between consciousness and the other parts of the brain that I don't know about. It's like it amplifies the feeling of being connected with everything essentially.
That's fascinating. Yeah. Cool. Yeah. I'm down with that, definitely. Jay.
Yeah. Are there areas in mainstream and Raelian science communities that could productively collaborate? And what guardrails would you insist on? Like what guardrails when you go into Raelian science do you insist on when you're collaborating with someone?
Collaborating with another Raelian or with another scientist?
Just another science-based community out there. What will be your guardrail?
Of course, I could not work on something that doesn't make sense to me. If somebody says, please, let's go to work on this Big Bang Theory, and then I cannot, because I
Yeah.
I cannot believe in it. But maybe I would just work on it to disprove it, but then I could be accused of being biased, of course.
Yeah.
Right. So right now, what I do in the real world is trying to work on things uh, that do not clash between my beliefs and my understanding of the universe, because either the work would not be very productive, or I would be accused of being biased in a certain. For example, there are some creationists that are religious, like archaeologists and other type of scientists, and try to show proofs that life was created and not evolved, and even people saying that dinosaurs exist at the same time of people, or dinosaurs exist. There are proof of dinosaurs much more recent
Yeah.
than than what is initially thought. And these people are religious, and they are discredited because they say, they use like this ad hominem argument, which is, this person cannot be trusted because he's religious. He's only saying that
Mm.
because he wants to
I
prove his
got
point.
you.
Yes, so I want to avoid that for sure.
Yeah.
Just to say, pop star in the chat says creationism and evolution can coexist. Yeah, exactly. You can have both, and I think it's possible.
Well, what happened was that, of course, Elohim arrived here, and they created life. They started to create life that is adapted to this planet. First, they terraformed the planet that is um, terraformed Earth
Yeah.
that is adapted to life, and then they started to create very simple organisms, because that was the science that they have, and then they start to evolve these based from this singular cell organisms until more up to more complicated ones. So that basically, so when you start to learning programming, for example, and on Python, for example, and the most simple program that you can make is the Hello World program, which is basically a program that it just says a Hello World, and then from that, and you learn more complicated functions, more complicated um, ways of programming, and then you start to make increasingly more complicated programs. And so it was the same. They programmed very easy type of life, which basically DNA, it's basically programming life. And so they programmed very simple type of life, and then it became increasingly more complicated, and that's why we see some sort of evolution in our archaeology, because that's what happened in their creation.
Yeah, I think increasing complexity is as time moves forwards, there is increasing complexity in the cosmos generally. That's measurable. As to moving on. Where are we? I think are we on block 7 now, Jay? Quantum tech, society, and some what ifs.
Yeah.
Are we going to move on to that one? Yeah. Okay.
Yeah, let's move on to that one.
Okay.
But first, let's do one thing. I know you had a question about what was it, gray matter?
Grey goo. Yeah,
Gray goo.
nanotechnology. Yeah, what are the very real world risks of the grey goo theory? And for anybody tuned in who doesn't understand what grey goo is, it's a nano robot that uses biomass to replicate itself and goes out of control and turns all biomass on the planet into itself, i.e. just like replicators. I think it was played out also in a Stargate TV show episode, but the term by von Neumann is grey goo, or clanky replicators. I think he came up with I prefer clanky replicators myself as opposed to grey
like
goo.
the Van Neumann probes, where they will come into the universe, come into a system, they'll collect all the materials they need to make another copy of itself, and another
go out.
copy, and another copy.
but on a nano scale, on a nano robot scale, you got 1 and then 2, 4, 8, 16, and then exponential as it's chewing through carbon atoms or any atoms it can get hold of to reproduce itself. And then the whole planet kind of devolves into a spongy mass of gray liquid. Yeah.
But
Scary.
does that exist? I don't know about it.
It's theoretically, well, I guess it's possible if you have a nano robot machine, you'd want to create more of itself so it can be more. You might have one robot create another copy of yourself and then program it to do X, but then the second one program so that you replicate yourself again and again.
Or they can come together and do something together.
That's right, yeah. But I think kind of the grey goo scenario is where it gets out of control and it can't be switched off.
Well, of course, that you would have to make a mechanism so that they can
Safety.
yes.
Yeah.
So that thing can be prevented.
But it is somewhat terrifying to release a small nanobot that just replicates itself with biomass.
I suppose that makes me think. It's not exactly the same. Makes me think of the Borg of Star Trek.
Pretty much, yeah.
You hit it right on the head there. Resistance is futile.
Futile, yeah, all that. That was my kind of like. I just before the show, I was discussing with Jay about like some understandings I have of limited understandings of nanotechnology and so on and so forth. Atom manipulation and molecular manipulation at the nano scale. Going back to what you were saying about kind of Elohim evolving humanity. Now we're at a point now where we have this concept of H+ human transhumanism, where we have like the potential to have a forced human evolution. So we take evolution out of nature's hands and we put it into our own hands. It's a bit concerning, hey, why wouldn't I want gorilla muscle density and just get an injection with a retrovirus and then kind of like change my organism, my genome. Literally that kind of whole concept is a bit worrying for me anyway, but hey, maybe I'm one of when they invented electric light bulbs and the gas lighters, the people lighting gas lamps were shuffled off. There was huge uproar as the electricity is the work of the devil, and it's terrible. And there's massive protests and riots, and it's like maybe I'm not quite one of those people, but I'm like, hold on, this could be a bad idea potentially. Like would I want to give another human being the ability to change my zygote, my whole genetic structure? I don't know. Maybe it's already happened, and I won't mention 2020. But anyway,
5G.
Well, like, hey, look, just like there's a dangerous flu. Go ahead, Jay. Anyway, over to you. It's my question. It's my question.
Yeah, what's your question?
Yeah. It's crack on. Okay. Dr. Natália Morais.
We can go to.
Is it Marie or Morais?
Actually, pronunciation in Portuguese is Morais.
Morais. Okay,
we'll
Dr. Morais.
Go to block 8 because then we'll that's the last block, and then we'll call it from here because it's been about an hour and a half. So
yeah, no problem. Okay, block 8.
We go about an hour and a half to 2, ma'am. But
wow.
We're gonna go through just some questions before we drop out. But that's why I wanted to get to the end real quick.
Yep. Okay. Sorry. Personal practice, mentorship, and the big picture. For you, what does a good research week look like for you? And how do you apportion deep work versus experiment versus reading? How do you balance everything with what you're doing with, and what does primarily what is a good week for you? Like, that was cool, I enjoyed that.
Well, there is every day I go to school. I never left school, so there is a good amount of studying that needs to be done, and sometimes I don't do enough. So I try to find the time to do it as much as possible because work sometimes it gets so intense that's difficult to find the time. And And of course, there is a reading of what has been done or what has been doing recently.
Mhm.
And there is so I usually do quite a lot of the segments that need to be done for experiment to work. So you have this simulation part where you imagine the device might work in a certain way, and then you need to confirm the functioning. So you need to make simulation of device simulation to confirm that it will work the way you expect it, and then you need to make it, and you need to fabricate it in a way that is conforming to the simulation that you've done. And then sometimes you do these iterations, so we cannot fabricate exactly the way you've predicted. So you introduce these errors inside the simulation. And so if that's good enough, then you use this fabricated device and you do your experiments with it, and you see that if your predictions are correct.
I think
Yeah.
that sounds like, to be fair, that's a full week. That is a full week. And I think if you're having full weeks and you say that they're good weeks, that's double thumbs up from me. I think that's kind of like, reading, experiments, research, understanding, moving forwards with the problem solving, moving forwards. That's it shines a light on my own personal not reading enough and not studying enough. So yeah, thanks for that. Definitely.
Right. Of course, the timeline that I just described, it's not a week. This is usually several months.
several months. Oh, good few months.
A year, or even several years. It depends.
A question for you: how often do like a eureka moments occur? Do you have you had many? You like, wow, okay, and then like a totally new paradigm of like fully understanding what it is you're doing. Is that a good week? If you get a eureka moment in a week, that must be a good week out of the months of what you're doing.
Well, I have eureka moments, several tiny eureka moments during the week.
Wow, cool.
Nice.
But it's like small ideas. Maybe if I can try this. Maybe I can try this. It's not really something paradigm shifting. But yeah, it can happen sometimes.
That's cool.
Maybe once every few years.
Well, I hope you have many more little eurekas, and then maybe a big one, which is what global shifting. That's the goal, where it changes and moves everyone forwards in a positive direction within the field that you're working in. Definitely, Jay.
Yes. What advice would you give young researchers who feel tugged by both rigorous physics and contemplative practice?
Contemplative, yeah.
Contemplative. I knew that word. I just can't.
It's a tricky word, man.
I'm not sure if I can answer exactly this question, but what I know that sometimes it happens that the young researchers, usually they work under all the older professors or older researchers. And sometimes some habits of older people tend to calcify, and this tends to can be passed down to younger generations, which is usually not good. But good thing is that younger generations usually are very dynamic and full of ideas. So I would say just to try to go around it and try to prove your ideas in a way that that can dissolve this calcifying elements on experimental teams.
All right, go ahead, George.
Great response there. Yeah, definitely. It's the younger generation who are full of the ideas. The older folk are maybe set in their ways a bit more. Maintaining that young, curious mind, asking the questions, is what it's all about. Definitely. Here we go. Okay. What is a belief that you held 5 years ago that you've just changed or updated? what's a belief that you like 5 years ago you thought this, 5 years of work, study, and understanding in all of your different aspects, from spirituality through to the physics. What have you updated or changed in those 5 years? And when you find something that you thought, I held this belief and now I'm here with this understanding, what was it that, what was the action that changed that what was the epiphany moment where you went from one understanding to a new understanding?
I used to think that creativity was inherently human, but now with the AI, we start to see that maybe it's not exactly the case. Even though creativity in humans still works in a very different way than than AI. Well, AI just basically uses everything that has been done to create something, but that creates something, but often it's not very rooted in reality. Sometimes it's not very rooted in reality, which are called hallucinations. Of course, people can also hallucinate and create something that is not rooted in reality, but I think the brain has this ability to connect, as I say, with the universe and with society and other people, which sometimes it brings you to something more real than AI right now can do for now.
That's creativity is not inherently in sorry, just to like what did you say? Creativity is not inherently human, it's in all things, or in AI specifically.
Yes.
So it's not just it's not just it's not just humans, we're getting creativity in other systems as well.
Yes.
Wow. Okay. I'm gonna take that understanding on board, and I'm gonna work that one for a while. Because I'm not the most creative person, to be fair. Maybe in mirth and making wisecracks, but yeah. Okay, Jay.
All right, so we've got some questions for you here, ma'am, and then I will give you the floor for a couple minutes, and we'll call it a night or a day for you.
Good morning.
Gary Barker has a question. Did you find the Raelian philosophy through science, or did you find science through the philosophy of the Raelian movement?
I think the question. Yeah, no, it was separated.
Okay.
I found science, and then I found Raelians, and somehow I
And
bring them together later.
okay, and then they came together.
Yeah.
Okay. All right. The next one is, oh, wait a minute, hide that one. We have another one here. What is the importance of her research, and what discoveries could it lead to? Planet Popstar.
Question: what discoveries?
So my research at the moment, specifically, as I said, it's electrons and liquid helium, and this is a very interesting system because, for example, the most common quantum bit right now, it's superconducting qubits. There are other types that you need to engineer these two-level systems out of block of material, out of superconducting material, or other out of a semiconductor. And electrons just simply have a very natural two-level system. We don't need to engineer anything, because when you engineer something and you fabricate it, it's going to be slightly different. You're going to have two quantum bits that are slightly different, and they don't work the way that you expect them to work, while electrons are very natural quantum system. So I think that could be interesting, especially electrons that are bound to a very pure environment, which is the liquid helium. It has no spin. It has very little interference, as opposed to other quantum systems.
Okay. We have a next question here from Tony. Does the guest believe we are being controlled, guided in a nice, bright way of humanity and womananity? Which That should be another word. That should be a word in the dictionary.
Womanity, yeah,
Womanity.
okay, or male, female, male. I don't know.
Yeah, both together.
Yeah.
So so Elohim created life on earth, right? And then they created human beings. But the human beings are not like other animals in the way that they cannot just rely on their programming, on their genetics. I mean, the animals are function through instinct. Some animals have some limited level of consciousness, and they learn with other animals. But people need to be educated. You cannot have a person that is not educated. So not only Elohim created us, they did not just let us like in the wild state in on earth, but they educated us. And how do they educate us? They send us prophets, and those prophets are at the origin of the major religions. And with each prophet came a big advancement in society, in a big advancement in the spirituality and the relationship between humans. For example, of course, for us it's obvious, but when these laws, these 10 commandments came, Moses brought these 10 commandments plague. One of them says, you shall not kill. For us it's obvious, of course you will not kill someone, but at some point it was necessary to say that, because people didn't know you should not kill others. So yes, of course. So and each prophet brought a message that is adapted to the state of development of a certain population on Earth. And now we have the last prophet that because we now are ready to understand the full picture, we are ready to, because we arrived to the age of science, we are able to understand that life can be engineered through genetic engineering, and we can travel in space. We can understand that. Before, something that came from the sky was inherently divine. It was God, and we could not understand how someone could come from the sky. But then we built the airplane, and then we built spaceships, and now we've been to the moon. We understand something can come from the sky and not be divine, and be just a human being doing experiments on another planet. And because we can understand that, they sent this last prophet to bring the last truth, so that we can understand and integrate this reality of the creation. Because it's important to understand that we have been created, because when we are created for a purpose, and evolution has no purpose. For example, we are just here roaming the earth by accident and trying to live, to survive. But when we create someone, we create them with a purpose.
Okay. And I have another one here from Tony. Does the guest converse with guides or spiritual ET godlike sources out of love?
With guides, well, in the Raelian movement, we have these people that we call guides, but they are people. They are not from outside.
Jerry!
They are not from outside of this world, and only Rael is half extraterrestrial. Let's say his mother is human, but his father. So his mother underwent artificial insemination with an extraterrestrial person with extraterrestrial DNA. So he's half human, half extraterrestrial. So, and that's the only person that I have contact with. I have no contact with other extraterrestrials.
Okay. Next question. Are there similarities between the brain and quantum computers? Planet Popstar.
Yeah, that's what we're trying to find out. And I think I feel right now the way that the brain can function, this sometimes we have a certain understanding of things, and in the classical computers and the classical way of understanding our brain, the processes are made sequentially, and it takes time to arrive. But when we have a transport of information and of like quantum state between one and the other, it's almost instantaneous. and which can explain this sudden epiphany, let's say, that sometimes people have, for example.
What I read the other day, Jay, that some scientists prescribe that the universe or the cosmos itself may be a form of brain, just based on the structure of it. So I
Quantum architect.
Yeah, for sure.
So one thing that Elohim said to Rael is that actually the universe is a some sort of fractal. This means that we are living right now in a huge. I don't know exactly the scale of it, but let's say we're living in a huge atom that belongs to a huge molecule, belongs to a cell, belongs to another living being right now. And on the opposite way, we in our atoms we have galaxies and solar systems with people and other living beings living on it.
Like the micro macro
Yes.
concept. Yeah.
And then we got one more question, ma'am, and then I'll give it to George for his final question or something to you.
Wow.
And
Okay. Crikey,
then
I've blown it
I
out, yeah.
will give it to you for the final comments. What type of brainwave is love measured in, do you believe?
Wow. I don't know. So maybe neither of these, because if it's a quantum phenomenon, then it would not be measured in electromagnetic waves, I think. So something extra.
Something extra. Okay.
That's my
And
speculation.
I give it to you, George, for your final question, comments.
Yeah, I just overall this interview we've had today with you, Dr. Natalia, has been really eye-opening and interesting for me to really listen to the research that you're doing on your current area of investigation. My limited Portuguese says obrigado, thank you very much, and bon dia, good morning. I know you're up early in Tokyo over there, so thanks for tuning in. Is the future positive
Well,
for all of us humans? Is it positive moving forwards?
it can be, or it can be very disastrous. So when when Elohim created life, they created life on three other planets two other planets, so three planets in total, because essentially they can predict that humanity has 1/3 of chances of surviving destruction by its own means, meaning they can reach a technology level that is so advanced that they can destroy all life on their own planet. And so apparently we have 2/3 of chances of that that happening. And every year Rael receives, because he's the only person that is in contact with the Elohim, and he receives every year what are the chances of humanity destroying themselves are. And this year in August, he received, it was a 50% chance. But mind you that before that it was 90 somethings. So we've improved, but we still have a way to go.
Okay, cool. I'm glad the future, even though I'm not a realism, I'm glad that there are people saying the chances of us making it through is better. And I think if love has a frequency, if love has a quantum effect, then if we promote peace and harmony amongst and be friendly with people and say hello, good morning, how are you, these kind of things out there in the real world, then I think it has a knock-on effect. To paraphrase J.R. Tolkien, even the smallest person can change the course of reality. So each of us has a personal diplomatic responsibility to promote positivity in our communities and everyone we meet. Awesome.
Well, love, it's in our programming, it's in our DNA, and it's very important to take care of our DNA and not do anything that will destroy them or damage it, so that we can preserve this ability of sending love to other people. And Elohim are very strict on that. We must not do anything that will alter or damage our DNA. So, this was a question that we had a while ago, right? So we must not do anything that might damage our DNA. Otherwise, we damage our programming, essentially.
Right. Well, I think I was made in a lab in '76, so I'm not quite sure I'm human.
Is there anything you would like to tell the audience about Raelianism or the movement or your sciences or anything to end the show tonight, ma'am?
Yes. So I can just talk about the essential points. What is Raelianism? As I said, as you know already, life has been created by Elohim, which is a civilization coming from another planet. And this civilization that we call Elohim, which actually means those who came from the sky, and we can find this term on the Bible, original Bible, some of the original Bibles in Hebrew, and it is a term that is plural. It's not a singular, and this word has been translated to God, which is a singular term. So
Yeah,
there has
gods.
been a mistranslation there, and it means those who come from the sky, which we usually tend to associate something that comes from the sky as divine, but they're simply people that can travel through space and can travel to another planets. So they created life on Earth, starting from simple organism until more complicated and increasingly more complex, reaching the human being. And they use genetic engineering for that, obviously. And when they created humans, they needed to educate them, so they sent prophets throughout our human history, so that we can be educated like a child would be educated at home by the parents or by the school. And so and 1945, which was the year that we made something terrible, which is an atomic bomb, and we used an atomic bomb to end the life of hundreds of thousands of people, which is awful. But what happened is that we found a way to manipulate the atom to give us energy. Not only destructive energy, but also we can use it to give us energy to fuel our civilization. And so they decided that we enter this age of revelation, which actually it's the age of apocalypse, as we can see in the Bible. But apocalypse doesn't mean destruction of humanity. It means revelation. It comes from Greek. It's a word that comes from Greek. It comes revelation, which is the age that everything can be understood through science. So 1946, Rael was born. So they decided to send their last prophet to reveal us the truth about our origins of the extraterrestrial creation on Earth, because it's the time that we can understand it. Before we would not be able to understand these complicated concepts. So now we are ready to understand it. So they decided to send this last prophet Rael to spread this message to the most amount of people as possible, and most of them will not believe us, but it's very important that they are informed, because they want to this Elohim, this extraterrestrial civilization, they want to come back, and for them to come back, we need to build an embassy, because they want to be invited. They are not trying to controllers. They don't want to invade us. They want to be invited by us because they respect us. So we need to build them an embassy so that they can return and transmit to us their scientific and philosophical baggage, so that we can finally create a golden age in our planet.
And on top of that, we have the Galactic Family Podcast is a supporter of the ET Embassy on their supporter page, because we support the ET Embassy and we want it to be built. We want humanity to move forward out of this this muck that we're in right now, this 50% range that he's talking about. And I bring up, you brought up a good thing about that quote that was the Bhagavad Gita, I believe it was called, which it's Oppenheimer when he had created the atom bomb and he had watched it go off, and he had said this. This is one of the things he had said right here.
He knew the world would not be the same. Few people laughed. Few people cried. Most people were silent. I remembered the line from the Hindu scripture, the Bhagavad Gita.
Vishnu the preserver
is trying to persuade the prince that he should do his duty, and to impress him takes on his multi-armed form and says, "Now I am become death, the destroyer of worlds." I suppose we all thought that one way or another.
That's intense emotions from that scientist, I think.
Oh,
Intense emotions as he's realized what he's created. But also, we have energy now. We have more of an understanding. So,
but thank you, ma'am, for being here and being a part of the podcast. I'm gonna let you get along with your day, and if you ever want to come back, if you ever make a breakthrough in quantum computing or in your any research you're doing, you're more than welcome. Shoot me an email and I'll have you directly back on, ma'am.
All right. Thank you so much.
Thank you very much, ma'am. You have a great rest of your day.
Thank you, Natália.
Bye-bye.
All right, everyone. That was Natália. Man, that was wonderful, man.
Intense. That was really intense. I learned so much from that. I like my understanding of the quantum realm has gone. Like I've got so many takeaways from the like literally the whole podcast there, Jay. That was intense.
Oh wait. We got to do this.
My brains are going into my feet.
Ludicrous speed.
Like,
speed.
oh my God, my braids are going into my feet. Like just listening to what she does, like her science and her. I got lost in the wording. Like it was like,
yeah. I'm like, okay, I thought I had a bead on this. I thought, like I knew that if you think you understand quantum mechanics, you don't understand it. But I actually thought I kind of knew a little bit. And then like I'm like, okay, so in the quantum realm, photons act as a probability weight, and then it's okay, it's flipped. Oh wow, that was amazing. That was so cool. Thank you, Dr. Natália Morais.
Yeah.
Morais. There we go, Morais. Thank you so much. Oh, just to add, anybody tuned in, we do have a Discord channel. Links maybe we can get the link in to the about description afterwards. We've got people coming in. A lot of the guests are coming in as well. So if you see the guests on the show, there's a good chance you can directly ask them questions.
Yeah, and we have some interesting things coming up that I was going to actually put up on the screen. The next podcast is a live celebration event on the November 12th.
Wow. Donating $1,000 to Pet Supplies. That is a great thing to be doing, Jay. Just think of all of the furry friends that we have who are less fortunate now, getting new toys, new food, new bedding, and more of just feeling better about themselves. I think that's what it's all about, isn't it?
Yeah, exactly, man. That's exactly what it's about. And we're showing our love out there, and everybody here is helping us along the way. We now have over 500 subscribers. Super chats should be on.
Yep.
Everybody's more than every single bit of everything you donate goes towards these programs that we are supporting, animal shelters, and then we are also going to be getting into the science more, into UAPs. We have Dr. Max also, who's going to be doing research that we can actually help him get his research out there and get peer reviewed. And there's a lot of other things that's going to be going on in the next couple weeks. We have Phenomenon Pulse coming.
Yes, I'm looking forward to this. Is it a weekly show that touches the pulse of what's happening with UAP, NHI, occult, paranormal, poltergeist stuff, things that are happening, the weird, the strange, the unusual, the curious, the wacky, all of these kind of things. We are going to go deep dive. We're going to tunnel in on, like, we're going to be tunneling like an electron tunneling microscope. We're going to go deep into these things and discuss some frankly amazing ideas and concepts that are current at the moment. So we're going to be
doing
bringing
it
you
for
the
a
best.
shitload of money.
Yeah. No, we're doing it for the love. We're doing it for the love.
No, my love is always out there.
That's it, man. We're doing it for the love. We're doing it for the love. And
I love Spaceballs, though. You got to have Spaceballs.
oh yeah. For
What's the
real,
matter,
for
Colonel
real.
Sanders? Chicken?
Chicken. No, we're going there. We're gonna bend the minds of the people listening. And just to say, on this premiere episode for me as a co-host of the GFT, we're going to be I find it really cool to be able to be working with Jay here. I think we've got a good chemistry and a good bouncing off each other. And just thank you, Jay. Thank you.
Oh yeah, man. I'm glad to have you on. And
that should read template.
it's a work in progress.
I
got another one. Wait.
Quick, bring another one of us.
I got the other one.
What's going down? We'll go.
Yeah.
There we go. Yeah, phenomenal presenting the VARA. Well, people are like the VARA template. The VARA template. Have you heard of this?
Well,
I haven't heard of it. I haven't heard of it. Where have you heard of it? I've heard of it on the Galactic Family podcast. That's where I've heard it.
Yeah, well, now you heard it again. Spelled the right way.
Yeah, people are going to be interested in this one. We're going to do a deep dive on the VARA template, and I don't think we should give any spoilers. I think we should let people tune in, and then they can say, they can talk about it with their networks. Yeah.
I'll give one spoiler, but it's not going to be a really spoiler. The past initiates the future, and that's all I'm saying.
Ooh.
So tune in for that. It'll be in the next that'll be coming up in the next couple weeks, after probably about maybe a week or two after we do the live next week. It'll be on let me pop it up here. I got another one here. Another image file that we can close this. Here we go. Boom. There we go.
Yeah,
So,
I'm looking forward to this one. I want to see all our little furry friends at the shelter there getting some cool stuff handed out by Jay and some other folk there. There's going to be, I believe there's a TV station is coming down, or a news station is coming down, or paper is coming down to report.
Yeah, we're going to have the local news station come down. And Natália, you are more than welcome to come back anytime you want. Thank 100%. You for being a guest.
My first co-hosting guest, and I think that went really well. I'm really interested. I've got so many takeaways. I'm gonna have to watch this podcast, and I'm gonna have to watch myself. He's gonna put the podcast through the AI so that the AI can explain and break down. Does that work now? I don't know. Maybe I don't think I should put myself through an AI. I don't think that's boy. That's not for the betterment of humanity. All right, guys. So we'll call it a night tonight on the Galactic Family Podcast. Like, subscribe, and just follow us, because we're going to be doing a lot of great things. Animals, people, and just all around trying to get the word out about UFOs and strange happenings going on. Keep it weird. Stay weird. Keep it weird. Awesome. Yeah. Weird, like spooky action at a distance, quantum tunneling, quantum mechanics, photonics, and like Dr. Natália Morais. Keep going. Keep pushing.